All right, so we were working along the lines of those exercises. I don't know how far you got. Again, your best friend is the docs, right? You will find what you need in this lab in here. If you really look through some of these things, you will find it. Sometimes the answer may be one line of code, or sorry, one line within a function. But anyhow, let's continue on. We got, let's cover this 25 slides, see if we can do it 45 minutes. And again, it's getting used to this new environment, but I do like Teams, new as a host. So let's continue on with what you've learned a bit. So we are still talking about arrays, but we talked about a very simplistic kind of way of looking at things. We're just gonna introduce data structures a little bit. I know you've heard about them. There's much more than these two. These are kind of, introduction to structures. We may talk about stacks and queues, but there's things as heaps and what's the other one I'm thinking about? There's a lot of different ones. Linked lists and lists, and we talked about kind of performance on this stuff and complexity. When you get into data, you will have to worry about that. For our purposes, we will probably be dealing with one-dimensional array for this class anyways. So we'll look at stacking queues, we'll look at some methods, more methods. Some might be already a review for you, and then some advanced data structures, just to know what they are. Maybe we won't use them, but just so you know what they are. As I said, there are courses and studies, computer science on data structures. So it's a whole thing itself. As I said, I did 2 full courses on data structures in university, and there's much more than that. But we'll do a tiny talk about it. So what you've been working with probably, if you've been doing the push and pop, we can look at this structure as a stack, if that's new to you. You can have the analogy of a physical set of items, like a stack of books, stack of DVDs, stacked on top of each other. In this kind of structure, we've been kind of thinking about a stack is a data structure that holds a list of elements. So a stack works on the last in, first out principle. You'll often hear it as LIFO. So last in, first out, meaning if you push something to the top, the most recently added element is on the top. That top book will be the first one that you remove off the stack. So as you're adding elements to your array, you can imagine that the first 0 element is the book on the bottom, and then anything else is added to the end, which in our case, we're going vertically. So it would be the top, right? If you shifted that around sideways, you kind of picture how your array would work, but a stack. So the stack has 2 goals. Two main operations occur. We've already probably looked at them, the push and the pop. So we push an element on the top of the stack, whereas the pop removes the element from that top of that stack. Last in, first out. So you can look at it like this. You can look at it like an ice cream, I guess, with layers on top, first in, last out, right? The bottom flavor will be the last one that you get to, that last one you get to if you work your way down. And it's supposed to be simple to understand this concept, right? So stacks are simple to understand. You can understand most of the properties by looking at that ice cream. As you know, if you get another scoop, you just pile it on the top. That's the first one. Hopefully you will eat, and then you will continue on down through there. So simply put, the first item in the stack is the last one to get removed. And the 2 operations, push and pop, is what allows you to do that. All right, so we can have a little concept of what a stack is, and I would like to share it. And once again, let's make sure that I am using my audio correctly before I start this out. I'm going to share with, it always defaults to off, but yes.
In computer science, data structures are ways to store and organize data so it can be used efficiently. Knowing about data structures is important because picking the right one can dramatically affect the performance of a program. Let's look at two of the simplest data structures, stacks and queues. First, stacks. The word stack in computer science is used a lot like it is in English, so let's think of a stack of books. If you want to add a book to the stack, you'll add it to the top. And if you want to get a book from the stack, you'll start from the top as well and remove elements. It's cumbersome to access a book in the middle of the stack, so we generally avoid that. A stack has a top and a bottom, and we can add and remove only from the top. In computer science, we tend to talk about pushing elements onto the top of a stack for adding, and popping elements from the top of a stack for removing. So a stack is a data structure in which elements are sorted by insertion order. The last element that you put in is the first one that's going to come out. Elements have no index, so we can't access them in the middle of the stack. We can only add to the top and remove from the top, pushing and popping. Stacks are useful in contexts in which we want to reverse the order of elements. For example, think about the undo button in a lot of applications. The application stores activities performed in a stack. And so when you press the undo button, the activity that's undone is the last one that was performed. Now let's look at queues. The word queue is not used in American English very often, but in British English it means a single file line. So let's think about a line at a movie theater. So somebody starts the line and additional people may join after the first person. And the first person to get help will be the first person who joined the lines. So queues have a front and a back, and we can add elements to a queue only from the back, and we can remove elements only from the front. In computer science, we might talk about adding as enqueuing and removing as dequeuing. Just like in stacks, elements in queues don't have indexes, so we can't access them directly. Again, think about the movie theater line example. The person working at the theater can't just ask the person in the red shirt to come and be helped. The patrons get helped in order. So a queue is a data structure in which, just like stacks, elements are sorted by insertion order. However, in queues, the first element that you put in is the first one that comes out. Again, elements have no indexes, so we can't access an element in the middle of a queue. We can only add to the back and remove from the front. Queues are useful in contexts when we're managing resources. For example, think of a print queue. If we have many people in an office sending jobs to the same printer, the first person who sends a job to the printer gets their job first. Similarly, if we have a website and several people are accessing that website, the first person who tries to access it is the first person who gets the page back.
All right, so those are concepts of data storages, but we know with what we learned with arrays that you know we know with arrays that it has a lot of built-in features. So concept of stack and queue, they were saying yes, in those initial conceptual designs of those to work in that way, you wouldn't want to remove, if you're using one of those structures in that way, you would not want to remove from the middle. But as we know with arrays, we do have options to do that. So like I said, there's various ways to store data. How you do it, you try to get a design and you work with the rules of that design. But the properties and the methods that are given to us allows us to do many things that we do in fact have options, many options to do different things. But in the context of what is a data structure that is a stack and a queue, those are kind of the basic, kind of description and rule sets of what those are from a high level. Right, some properties we already know about the length. We already we figured that out already. What the length is, array.length, it sets the returns a number of elements in that array. we have this array here with the literal, literal with the square brackets, shoes, shirts, socks. We find out that the length of it is 4, which is true. However, if you were, again, to access the 4th element of the array, it would be undefined, right? Because we have that the zero numbering system, where this is the first element is 0, so we could not get to this point here where we were accessing the 4th element, because that would be undefined, right? If we were to output that, it would be undefined, because really it's the length minus 1 to get at the true, to do that offset that we need to do. If you look at the docs for length, it's a property, as we said, returns the number of elements in the array. In the same way, you can run that and you'll get that amount there. Right, so again, that property is sitting all by its lonesome up there in array properties length. There's not too many, most of them are all methods, as we can see. All right, so really, there's really only one property to talk about, and that's the length, and you're going to use it quite a bit. Methods, so we already established these ones, right? Push, pop, or for stack. Shift and unshift is for queue, but the push is what it's pushing that book on top of the stack. So the push element adds 1 or more to the end elements and returns a new length of the array. So we have this array already set up. We already said we push it. Again, it doesn't matter if you push on true, false, 0, undefined. Obviously, it affects the count. And then if you output it, you'll see the new element that has been added to the end of my array, right here. It's not to the front, it's to the end. If you were to shift this entire array vertically, this would be the top, like the top of a stack of books. So there you could do it in this way. If we wanted to manually add all of these elements here, you have an empty stack that's initialized up here. Stack equals an empty array. We push 1. The stack has an array of 1. Push 2. Same thing, the array is growing. Push 3. Now we have 3 elements, 4 and 5, and so on. Again, it's growing this way to the end. If you look at this context of the picture, you'd be able to see what's happening here as you're building the stack. Again, we're going vertically here, so it makes more sense to us. But if we're dealing with in a row that's kind of horizontal row, it's going to go to the right. It's going to go to the right. So initially, the stack is empty. Every time we call that push method, we add a number on. We push a number to the stack. As you can see, 1 gets pushed, 2, 3, 4. When we get to 5, you can see we have all elements there, and they're pushed on in that order. The other element is the pop that goes along with the stack. Again, it doesn't, but this one doesn't take a value. It's basically an empty function call. So you could, if you can imagine, inside of this array, there are a list of functions. I called them methods because I'm thinking about object-oriented programming, but we're functions. It's really a function attached. When it says pop, it knows what to do internally. Internally, it probably does a calculation on the length of the array and probably figures out the size of it, figures out the offset, and it adjusts, and it takes the last element and it removes it. It can do that in many different ways, but you don't need to worry about how it implements it. You don't need to worry about the internal implementation. You just need to know that when you call .pop, it'll actually remove the last element, which in this case is the tomato. The method changes the length of the array, yes, because it's actually modifying, right? It's modifying it. So as we see, if we output it, we're going to get everything less than that one we popped off. So we get 4 elements: broccoli, cauliflower, cabbage, and kale. Again, in the same way, if we had started with 5, an element, if we'd started with 5, if we see at the top there, we console log the pop, it'll return the value that we are outputting, which is 5. And then we see what we output what the current array stack looks like. And then we go again, we pop off the top. And then 4 is removed because the pop operator returns the last element. Again, we go down in this way, in the same way. If it looks repetitive to you, it probably is. because maybe this should be done in a more elegant way. Maybe it should be done in a for loop or a while loop or something like that. And you don't have to write this code so repetitively. Finally, the last pop will just return an empty array at the bottom here. If you do notice, if you try further to, wait for this to hover over it, if you try to keep initializing or calling pops against an empty array, it's just going to return undefined, because the value coming back from what you're removing is nothing, because there's nothing to remove. Again, it doesn't bark at you or give you any indication that you're trying to remove an element that doesn't exist. It's just basically saying that I didn't remove anything, therefore it's undefined. And you can keep calling pop however much you want, but you're not going to get anything back until you add something else on top of it. Push and pop, just so you know, related to stacks. Same deal, array pop. Initially there are 5 elements, removes the element at the end, and all the way to the end, as we said, it'll basically remove that one there. If we look at the lookup here, so somebody had some question. Is this a video? It was a video. Right, when we look at, if you want to read more about push and pop, again, in your web docs, we can see pop. It will have that example as well, but it'll probably have a little bit more references to shift and unshift, which is similar to pop. And when we talk about those, we're talking about queues. And then it gets into some more advanced stuff down here. And then obviously the browser compatibility, if you look at what supports it, very important. Internet 5.5, you can see that pop is pretty old. It's been around for a while. If you're looking at IE5, you know that it's been part of the language for a long time, because IE5 was probably, I don't know, maybe I have to see it, probably at least 10 years ago, maybe 15. I can't remember exactly. Long time. So you can imagine that this has been around for a while, these two, because stacks nothing's changed much in the science of stacks. Another great one is the sort. Yes, you could quickly sort it. Of course, you could iterate through the entire contents of that. You could iterate through the entire contents of that array, and then try to figure out how to sort them. That's a pretty complicated piece of code. And you basically sort it in descent. Its default is descending there. So probably internally, it's looping over all of those, it's reconciling, and then it's creating a new array, and it's outputting the new array to us. That's probably what it's doing. It's probably doing some crazy stuff inside of it. Right, if we had an array that had a bunch of numbers in there, it's probably, I'm not going to code the entire mechanism of it, but it's probably internally doing some kind of, just hold on, I'm going to be interrupted here. Sorry about that. I'm bribing my youngest son with Minecraft, so he will please be quiet so I can finish up here with you folks. So apparently I have to get some bucks for Minecraft. So yeah, that's where some of my teaching money is going right now, is to keep people quiet. What was I saying? All right, you could start off, you could do something like this. You could have, all right, the length of the array, the length of it, right? That array minus 1, something like that. We'll have to see how it runs, and then we increment it, right? This is just showing to traverse over this array if you needed to. There are more built-in features for this. Again, I'm using this REPL because I know what this means. You can also, again, use your Visual Studio Code and run it inside the browser to step through it all, right? If you need it, if you so needed to. And they're probably, they're probably going through each element here. Who knows what they're doing? They're probably saying, maybe they're checking the current value of the number at that index of I, right? And maybe we can just start it out like this, see if it runs. All right, doesn't like this, doesn't like my incrementer. It doesn't like the fact that number is not defined. At least it's telling me. Thank you for telling me, guys. Thank you for telling me, compiler, sorry. All right, so what they could be doing and what you could do is you have another array, which could be like sorted array, which is empty. And maybe you are comparing the previous value. Like, I'm not going to do the entire thing, but if you had like a previous number that was, you had like a key that was 0, and every time you set the current one, you could check, is the current, greater than the previous one? If so, then if it is, something like this, you could say sorted push the current. I'm just thinking about this out loud. I may not actually do what I want. And then you would say at the end that the previous now becomes the current or something like that, or the biggest, is current bigger than previous? If it is, then, something like that. Anyhow, the point is at the end, they would probably return that sorted value at the end. See, it takes a little time to think through it. This will probably give us something else. Return sorted or console log sorted. The point is, see, well, it basically gave us right back what we wanted, but if we put 12 in this, would it actually sort it? Maybe it wouldn't because my logic might be off. Somehow it's actually rearranging them in some way. The point is, you don't need to worry about this internals because we created a sorted array. We're trying to go through and push it. We're trying to do some logic here, but at the end of the day, if you wanted to actually sort this thing, you could just use a built-in feature and not have to worry about all that and say numbers dot sort, something like that, and it'll sort it for you. Now, did it sort it correctly? It actually said 10, 12, 3, 4. So it did something else for us, and we'd have to look at what it's actually trying to do. Now, maybe what did it do properly? Sort. Let's see what it did. Maybe it didn't compare the numeric values correctly in the same way. It actually did kind of, what it does, and this is what's weird, is it'll actually look at the 1 and it'll look at the binary 100 and figure that they're closest. That's really weird, isn't it? And then they actually look at 21. It looks at the first value. So it doesn't sort exactly how we want it. So let's read it. Sort method sorts the elements of an array in place and returns a sorted array. The default's ascending, built upon the elements into a string, comparing their sequences of the UTF-6 16 code units. So it does a conversion and it checks the UTC-16 code units, and that's what it does. So it actually doesn't do as we expect it to do, which is a little strange. But as we said before, each string value has a numeric value, a UTC code. I imagine each number as well also does. So you will get this weirdness happening. So maybe you need to dig further and then do like a classic sort or something like that. Some strangeness around that, but that's one option there. Again, internally, you don't need to know how that works, but it does actually help to know that it's sorted in UTC-16 code, just so you're not getting these strange result sets that you're not expecting here. As you see in the bottom here, 0, 1, 10, 2, 20, 3, and 30. All right. So maybe in this case, one line of code is not going to work for you. All right, so the includes, however, this one may, because this can determine whether an article includes a certain value amongst all the entries, returning true or false. So here's a quick way of quickly finding if that value is in that array. So we are searching for 2. It's going to find 2 in there. It's going to output true, which is fantastic. I don't have to loop around that array and compare everything. Much like I was trying to do in the other one to sort. Same thing with the strings as well. I'm searching for cats. Same thing with, and it'll return true, false, which is great. As opposed to, could we do a while loop on there? We could. We could say while I, if we set up I as an integer value here, and why I is less than the length of the array, to continue that, numbers.length. But we will break if we find something in there that that if we were searching for a value which we want to find, this is what we're looking for. Number defined equals to 4. If number defined, number to find, is equal to that value in the array, that index, then we would break, right? At that point, we break execution of the array, right? Otherwise, continue. Something like that, but we don't need to really worry about that because we could think through that logic and make a function, but really we have this option here that's already built. It says numbers dot, what was it again? It was numbers dot includes. Does numbers includes 4 or 3? And it should return true for us if it's right there, which it does. Otherwise, if it was 300, it doesn't return 300 at all. It returns false. So again, learning to use the docs, I mean, that's there for us. We could certainly write a function to do this as well and handle all the cases, but it's best to use the built-in methods where possible. So that's includes. You're going to use it quite a bit. Index of, I'm sure you'll use it in your lab, returns the first index at which a given element can be found in an array, and -1 if it's not present. So we have another array here, and we're checking to see if Bison is part of it, and it's going to give us back that index. It's at position 1. Same thing there with start from index 2. So we are actually saying is this the index of 2? Otherwise, it's outputting 4. So that one's a little bit strange, to be honest. It's saying, let's read that one, because why is that one the case here? Oh, this one is actually showing some, well, let's look at our docs here. Go to our docs and we'll look at index of prototype onto the array, returns the first index at which the element can be found, -1 if not present. But it also has this, I don't actually use this, to be honest, that much. Start from index 2. Start at index 2. Expected output is 4. So that's strange. I guess it's actually starting at 2. Okay, it's probably shifting it. So instead of 0, 1, 2, and 3, it's actually doing some shift on the position, which is a little strange. To be honest, I wouldn't use that too much. It may be a little confusing, but there's a little bit of markup on it, what that would mean. It's optional. I don't usually use it too much, to be honest. I usually use a straightforward approach, which is just show me the index, output where it is. Again, each of these ones have more advanced features than maybe what I'm showing you, and there may be cases where you might need to use some of these advanced features. Again, those are the docs. When you scroll down, you'll see some of it. So here is this index of. So we are searching forward. So index 10 returns 0, 32, 50 is not in the list. So of course we're going to get -1. And then if we actually find it again for 20, it'll return 1. So key thing to remember is it'll return you the exact position in the array, which will be an integer. If it's not found, you will get -1 back. So if you had a conditional based on, hey, did I find this in the array? If the return value needs to be greater than 0, then you found it. Otherwise, if it is not, that means it's a -1. Therefore, you did not find it. So I think there's a question in the labs that also kind of talks about that. In a way, you can kind of think that through. We already talked about this one. This one's a very quick one in case you need to determine that the value that you're getting is actually an array, in case some people try to pass in some of these other strange things. If you have an array function, you might need to pass in isArray. So it'll check that the fact it is. If you try to pass in an object, a string, or undefined, it'll do that check for you. Much like those built-in features like is not a number, is nan, and some of those other types of things and checks you might do with int parse and those kind of things. Useful tool set. Advanced data structures. We may have already talked about a queue, but let's look at it again, just because we may not be using queues in this course, but it's good to actually know what they do a little bit.
In this video, we're going to look at the queue data structure. And again, I probably shouldn't use the term data structure since we're not going to be looking at any particular underlying implementation. So if we're not looking at any underlying implementation and just talking about the operations associated with something, then we should be referring to it as an abstract data type and not as a data structure. But hopefully, since I make that distinction or that disclaimer at the beginning of the video, even though I use the term data structure, that you'll know the difference. So what's this queue all about? The queue is just what we call a FIFO data structure, and FIFO stands for first in, first out. So it just simply means that the first item that we add in to our queue is the first item that we would remove from our queue. And this is exactly opposite of what we had with the stack, which was a LIFO data structure. So it said that the last item that we added in was the first item that we removed from the stack. So the queue should be a very familiar structure to us. So it kind of models this idea of waiting in line. So if you've ever waited in line for something, then you really have a good idea conceptually of what a queue is all about. What we're going to talk about in this video is just simply the terminology associated with this queue abstract data type or queue data structure. So we'll say that maybe we're at an amusement park and we have a roller coaster ride. And right now we have some people that are currently riding this ride, and we have a line, and right now our line is empty. So we could say that our queue for this ride is currently empty. Or we could say the size of the queue is 0. And then all of a sudden we have a lady that comes up and she gets in line for this ride. We would say that this lady is now in queued, or she has been pushed onto the queue. And I know pushing is not really a polite term when you talk about lines, but in terms of the data structure or the abstract data type, we would talk about the item being pushed onto the queue or in queued. I kind of prefer the term in queue because it kind of separates us from the idea of the stack, and we use the term push for stack. But push is often used as well for the queue data structure. So this woman here represents what we call the front of the queue or the head of the queue, and she also represents, since she's the only person in the queue, the tail or the back of the queue. So our queue now is of size 1, and this lady represents the front of the queue and also the back of the queue. And then we could have someone else. So maybe we have a gentleman that comes along and he's interested in riding the roller coaster as well. And we would say that he has now been in queued. So this now changes the size of our queue from 1 to now 2. We have 2 people that have been in queued. And this lady is now no longer the back of the queue. She's still the front of the queue, and we could also say she's the head of the queue. But this gentleman here is now the tail of the queue or the back of the queue. And then we could have maybe another person that comes along and he gets in queued. So we did another in queue operation here. And for whatever reason, he has a microphone. So maybe he's singing or talking to people on a loudspeaker. But he's been in queued, and he now becomes the tail of the queue or the back of the queue. The lady here is still the front of the queue or the head of the queue. And this gentleman here really doesn't have, a specific name. He's just in the middle somewhere. So with the queue data structure, you'll usually have an operation that allows you to access the head or the front of the queue, and you'll have an operation that allows you to access the tail or the back of the queue. But you don't have any mechanism to be able to access anything in the middle of the queue. So let's add one more person to our queue. So we'll push on or in queue one more person. And so we now have a queue that's of size 4. The lady is still at the front of the queue, and this gentleman here that we just in queued is now at the tail of the queue. So what we've seen here is that every time that we do an in queue operation, we in queue the new thing at the end or at the tail or at the back. And that is a restriction or a constraint with the queue data structure, is that any item that we're enqueuing or adding on has to be added on to the tail. We cannot add something to the middle, we cannot add something to the front, it has to be added to the tail of the queue. So now that we have these 4 people in our queue, so we have a queue of size 4, let's look at doing the operation of removing someone from a queue, and that's what we call dequeuing. And dequeuing only occurs at the front or the head of the queue. So again, this is a first in, first out data structure. So the first person that was in line here will be the first person that's dequeued. And we can imagine them being dequeued from this line and being able to get on the ride. So I'm going to say that this lady here is now being dequeued. So now that she's been dequeued, this gentleman here now becomes the head of the queue. So if there's more space on the ride for him to get on, then he can be dequeued. So we can imagine him being dequeued. Again, every time we do a dequeue operation, it has to happen at the head of the queue. So now this gentleman here with a microphone is now at the front or the head of our queue. So that's pretty much what's going on with the queue in terms of the operations. Typically, we can get to the front of the queue with a particular operation. We can get to the tail of the queue. We can do enqueuing, which occurs at the tail. We can do dequeuing, which occurs at the head. We can get the size, and we can also usually test for empty. So in terms of uses for the queue, certainly as we've seen here, we can simulate waiting lines. Typically, you'll also find a lot of queue data structures within computer systems for buffering input and output type operations. So you can think about maybe a print queue. So if you have a network printer where you have multiple computers tied into that particular network printer, you may have lots of job submissions, and they want to print those jobs out in maybe a first come, first served basis or a first in, first out basis. So those jobs would be queued up inside a memory buffer within that particular printer. And the same idea goes with keyboard strokes. So as we type on the keyboard, then there's a buffer there for that input to keep track of the keys that we pressed in the order that we pressed them. So we want to make sure that whenever these characters show up on the screen, they show up in the same order that we typed them out on the keyboard. So they would be inputted into a buffer, a FIFO buffer, first in, first out buffer. And the same thing can be thought of with frames in a video as well. So that pretty much covers everything that I wanted to talk about for this queue data structure, at least from a...
All right, I'm sure you probably get it by now what queues are, but it's good to this practical uses, you know, buffering, especially in Node.js. We're going to talk about buffering quite a bit and how it handles data, and also call stacks. Right, when you're working with the call stack, it's actually a stack of errors. You'll see it in your browser when you look at your developer tools. So there's something called a call stack in there, which will give you your errors that you can see, look into. On this side here, there's something called call stack, and the errors will be in the same way, pushed on the top, and you can traverse the stack. Anyhow, we have 4 slides, no more videos, and then we can just quickly wrap up, and then you can go back to breakout rooms and get some great help from tutors if needed. All right, so we talked about queues, right? We know what a queue is, ordered list. We already kind of established that. Insertion at the end of the queue and removed from the front. Now this is a paradigm, right? We know already in JavaScript that we can remove from the middle because we have all these methods that they're generic methods. So don't think of an array. Think of an array as like a data storage item. How you store the data is up to you. Whether or not you store it in a design such as a stack, or you store it in a queue, or there's other ways of heaps and things like that. They basically provide you with all the tools, and you decide how you want to, the mechanism for which you need to make that data storage work. If you take the paradigm of a queue, then it works in this way. It's unlike a stack, which is a LIFO, last in, first out from the top, push pop. We are first in, first out. So we're adding to one end, removing from the other, FIFO. So again, right here, we're having the enqueuing and the dequeuing. We already kind of established that. Enqueuing is the The insertion operator is NQ and the removal is DQ, and it happens from the back and the front. In JavaScript, we use the push at the end of the array, which is similar as the NQ operations. We're using push, and then we use something called shift. So shift is similar to DQ. So to note, there is not actually an operation called NQ and DQ. There's actually something called shift and unshift, push and pop. Yes, and one thing to note is there are multiple dimensions to arrays. We may not cover this. This is where it gets really strange. It's just worth knowing that we're only working in a one-dimensional array. So, but you may have, if you can see here, a one-dimensional array. Here's what we're working with. You may have two-dimensional arrays, right? You may have two-dimensional arrays, and you may also have three-dimensional arrays. And when you are working with three-dimensional arrays, it is very, very, very strange and very complicated sometimes, the logic, because you can not only have a linear, you can also have vertical and kind of a horizontal, vertical, and I guess that z-axis, right? You have to work it. It gets very weird. To be honest, I don't have too much experience with three-dimensional arrays. Two-dimensional arrays, yes. Three-dimensional, that I haven't spent too much time with big data to get into three-dimensional arrays, but just know about them. It's very weird because then you have to, you're not just dealing with one axis, which would be, one index. You'd be dealing with all three across three planes, right? So you'd be dealing with, 1, 1, 1. So it'd be that block, right, in that axis. And it gets really strange. How do you access the ones on the back, right? Would that be the first element here and the fourth element? So 1, 4, and 1, something like that, like the coordinates, right? The coordinates of that, this would be, you can already tell. I'm already probably confusing you just talking about it, but you can imagine coding it, right? So let me get out of this. So just wanted to let you know that there are more advanced structures. It's worth a read as well. I mean, there are things, if you search data storages, there's something called heaps that look like that, and there's linked lists that look like this. There's complexity around all of it. Data structures itself like I said, is a science in itself. Like when you're dealing with big data, you need an optimal way performance for doing queries and things like that and lookups. You don't want to just basically delete something from the tree and then affect the entire array, especially if you have a million elements. It's not really good for your performance. So, all right, with that being said, I did open up the assignment. Yes, go ahead.
Okay, Mike, regarding the exercises, so
Yes.
do we, like just we see on the first bullet point, take a parameter, my array, which will always be an array. So do we have to introduce some sort of validation in our code to check that?
I'm making the assumption that it's always an array right here. Yeah, I'm not expecting you in this unless I state otherwise or unless you want to. You can certainly check that it's an array. It'd be good practice to check. It would be. But in my example here, you can see I'm only passing in arrays here, right? So
Yep.
yeah.
Okay, I guess it's the same with the challenge one as well. There is no need for any validation unless it's like a nice to have, of course.
Yes. You're right. Yes. So this one, yes, you're right. Unless I throw a curveball at you in the response, you have to look up if I actually put a true false and it would say not an array, then assume that it's always an array, so you don't have to worry about that handling. But it's perfectly a good idea to check for it. It's good programming. So this one, if you made your way down, this is finding the index. So it's basically saying, okay, find the position that it is in. And if you followed along to whatever I have said, you may have picked up on something already that can help you out. To simplify this greatly, otherwise you will, if you weren't paying attention and you weren't listening or you're not even here in this class, somebody's going to try to do it the long way, and it'll be fun for them. But just know it's probably found in one of these docs somewhere, right? In one of these, maybe it even sounds like index, maybe. And it's just playing with these properties really is what the point of this is. This one is has a number. Does it have the number? Does it include the number? Maybe. Again, I would expect all these exercises you could find the answer. You could find an operation or a method already on the array. If you get to the challenge, basically this is kind of a string lookup, but at the same time a string can be converted to array if needed, and you're kind of doing some kind of operations on it so that if these characters are passed in, it'll actually break it up and try to decode it in some kind of strange way, so on and so forth. So let's work on those. I know we are at 9 o'clock, so like I did wrap up the lecture part. So let's go to 9:30 in the rooms. I'll leave it to you to join, and but let's come back at 9:30 because I want to go over at least 25 questions of the midterm, or sorry, the previous exam. Hopefully we can get through them all, but if we only get through 25, that's fine. And then we'll issue you the quiz, and then hopefully you'll have a good weekend. So let's go to the breakout rooms, work on our lab, and come back in 25 minutes. All right, guys. See you then.
Mike, there is one question regarding the reverse. That's
Sure.
in the.
Yes.
So, okay, there are two ways to go about that. The first is to use the inbuilt function, and the second is to kind of hard code it ourselves. I think exercise 3.
Yep. Yeah, that's
So,
true.
so which way should be the preferred one, the function one or?
Well, I would say create a function, but inside of the function, you may do whatever is best to you, whatever you feel is most
Thank you.
optimal for you. Yes, your discretion, but maybe use a built-in function for that. All right.
Well, yep, but if you're actually going to use the built-in function, then there is no need to declare a new function. So perhaps if we actually went through the process of hard coding what is happening behind the scenes, that might be the better. But sure, it's totally should be up to.
Yeah, I would say you could do both to understand how to do it. Like in my probably solution, I have both. I probably say this is how you would do it the long way, just so you understand. And then if you didn't want to go, if you knew that there's a built-in method, you could just call it built-in method for sure. But in my solution, I have both. So I didn't actually cover it in the lecture. It was more about, hey, I found this in the docs. Can I use this? So you're already asking that question, which is good.